This is the setup video for the Ohms Law Lab. So in this lab, you're going to start off by using the final circuit that you constructed in the Circuit Basics lab. Okay, so I have that still all set up here from last time. And the only thing we're going to do different for this first part for the setup is that we're going to take the red wire, okay, where it's plugged into the 3.3 volt port, and we're going to move it to this port called DAC. That's over here below the high gain sensor. Okay, so we're just going to move that over, and that's going to allow us to vary the input voltage coming from the IO Lab device. Okay, and so what we'll do is, in order to use that, we're going to go over to this in the software, this little settings button, the cog wheel, and we're going to click on expert mode and then output configuration. Okay, and you can see what that does is underneath the sensors list, it creates this output and a couple extra buttons here for output. And so we're going to use the one that says DAC output, and it's automatically set to off. So we're going to click on there, and you'll see that it automatically goes to 1.8 volts. Right, so we're going to switch that, and we're going to put it to 0. And so one thing to be careful of with this is that if you don't use the software for several minutes, you know that it will time out and shut off, and then you'll have to reconnect. But when that happens, the DAC will turn off as well. You'll have to turn it back on, and you'll have to, it'll automatically go back to the 1.8 volts. So you have to change that to the voltage you need to use. Okay, and so we're still plugged in measuring the high gain sensor, okay, which will tell us the current because we're using the 1 ohm resistor that we're measuring it over. So we'll be able to measure the current going through here. And so we'll vary the voltage, and by doing that, we'll be able to see what happens to the current as we vary the voltage. How does the current change as we change the voltage? Okay, so I'll go ahead and open up the high gain sensor. And you remember in the previous lab, in order to get the accurate current, we had to take a measurement and then reverse the leads and take the average, right? To get rid of that offset voltage. Well, now there's something a little bit easier we can do here, since we're using this DAC port and we're able to vary the voltage. Okay, we can actually discover what that offset voltage is right now. Okay, so we put it to 0.0 volts, so nothing. And so if we click record, we'll see that, well, it's not showing quite nothing, is it? Right, I can click and drag over it, and I see it's minus 0.021. Okay, so that's my offset voltage. So using this DAC port to control the voltage going into the circuit, we can actually just say, okay, whatever the reading is on the high gain sensor, we have to add 0.021 to it. Okay, so like for this here, since I'm at 0 volts, if I add 0.021 right to the minus 0.021, I'll get 0, which we know is the actual voltage going into the circuit. Okay, so for me, I'm always going to add 0.021 to everything I do. So then we're going to do 0.5 volt intervals. I'm going to increase the voltage. So I'll start at 0.5. I'll continue. Okay, and then I can click and see what this is. I see it's 0.041. Okay, but I have to add 0.021 to that. Okay, so 0.021 added to 0.041 is 0.062. Okay, so that's the actual current flowing through there. Okay, the 0.062. when we are applying 0.5 volts, okay? And then you'll just continue going up at 0.5 volt intervals and all the way up till you get to 3 volts. And there's a table in your lab report document that you can put in the current. Okay, and then there's a few other things I'm going to have you do there. You're going to make a graph, and then from that graph, you'll be able to determine what's the true resistance of your 10,000 ohm resistor. Okay, so I'm not going to walk you through everything in here. I'm just going to, in this video, I'm going to help you set everything up. But be sure to pay attention to the instructions in the lab manual so that you know everything to do. I'm not going to say everything in the video, okay? And then we're also going to see how the current changes if we change the resistance, okay? So what we'll do is we'll use one of the 4.7 thousand ohm resistors, okay, and they come in this bag with the JO ends in JO472. Okay, so that's what those are the 4.7, all right, or 4,700 ohm resistors. So they're about half of the 10,000 ohms. So we'll kind of get to see some effect of what happens when we cut the resistance in half, okay? And so I'll just take out that 10,000 ohm resistor and I'll plug in the 4.7 thousand ohm resistor right in the same spot. Okay, and then we can repeat what we just did, where we change the voltage, increase the voltage at 0.5 volt intervals, and see what happens to the current in this situation. Okay, and then in the part 2 of the lab, you're going to look at how current, voltage, and resistance, or all 3 parts of Ohm's law, behave, how these 3 quantities behave when they're placed in a series circuit. So a series circuit has only one path for the current to flow through. Okay, so technically we've been creating series circuits this whole time, right? Because the current had to come from the power source through the one resistor, through the other resistor, and then back to the ground, okay? And then that formed our pathway, okay? So to see how these things behave in a series circuit, what we'll do is we'll put the 10,000 ohm resistor in series with the 10,000 ohm resistor. Okay, so the 10,000 ohm resistor and the 4,700 ohm resistor we'll put in series. So I'll put, just to keep it consistent with the picture and the instructions, I'll put the 10,000 ohm resistor back where it was. We'll take out that 1 ohm resistor for now, and I'll put the 4,700 ohm resistor, like how it is in the picture, between row 7. Okay, and looks like row 17. And then the 1 ohm resistor, which acts as our ammeter to measure current, I'll put that between 17 and looks like 25 in the picture. And so there's nothing special about these holes. It's just you could put them whatever holes you want, as long as you do it the way the breadboard works. I'm just trying to keep it consistent with the lab manual in case you're wanting to follow along with that. Okay, and then we'll measure the current. So if we want to measure the current, all right, we want the end of the circuit to be at the end of that 1 ohm resistor. So we'll place the ground wire at the end there. And then if we're going to measure the high gain, use the high gain sensor to measure the current. I'll move the high gain wires so that they're measuring over that 1 ohm resistor. Now you can use the same method from part 1 to determine what is the total resistance in this circuit. Okay, where we have basically the 10,000 ohm resistor and the 4,700 ohm resistor. So you can take those measurements and from the slope determine what's the true resistance in the circuit, and then you'll be able to figure out you'll be able to make a conclusion about how resistors behave when they're placed in a series circuit. Okay, and we call this total resistance. We call it equivalent resistance. So what a total resistance of a circuit is equivalent resistance, and we'll represent that with the R with a subscript EQ. Now, if we want to see how voltage behaves in a series circuit, what we can do here is we can go ahead and get rid of our ammeter. We're not going to measure current, so we're just going to worry about voltage. So we'll just see a series circuit with a 10,000 ohm resistor and the 4,700 ohm resistor. Okay, and then instead of using the high gain sensor, which remember helps us to measure current, we're going to go back and use the A7 sensor. Okay, and so to do that, we'll move our red wire, our power wire, from that DAC port, and we'll put it to the 3.3 volt port. Okay, and instead of using the high gain sensor, we'll use the A7 sensor. So we'll move that from the G plus to the A7. Okay, and we'll just take our white wire out of here for now, and then our ground will stay in the ground, but we'll have to move that so the ground is at the end of the circuit. All right, that way we have a pathway from the power through the first resistor, through the second, and back through the ground, and completing that whole loop. And then we could, to measure the voltage over the 4,700 ohm resistor, I'll put the A7 sensor there in row 7. So it measures, remember, the A7 sensor measures between the A7 port and the ground port. So if we put it here, so it's just over the 4,700 ohm resistor, then we can measure the voltage over that resistance. Okay, so you can go ahead and do that. And then if we want to measure the voltage drop across the 10,000 ohm resistor, what we'll have to do is we'll just swap. Okay, so we'll swap the positions of the 10,000 ohm resistor and the 4,700 ohm resistor. Okay, and then again, you can use the A7 sensor to measure that voltage. Okay, and then the final part, in part 3, we're going to learn how these quantities work in parallel circuits. Okay, so how does all the parts of Ohm's law, voltage, current, and resistance, work in parallel circuits? So in a series circuit, there was only one pathway for the current to flow through. But in parallel circuits, there's more than one pathway. Okay, so the first thing we'll do here is we'll put the 10,000 ohm resistor and the 4,700 ohm resistor in parallel, we say, and then we can start out by measuring the voltage across each of those. Okay, so I'll try to keep it like the picture, and I'll put 4,700 ohm resistor, which it looks like I put them in row 9. It looks like I was putting the others in row 7. So try to keep it consistent with the pictures, but it doesn't have to be exact. All right, so there's our 4,700 ohm resistor, and then I'll put my 10,000 ohm resistor in parallel with it. So that means they're going to be in the same rows. Okay, and I'm going to take my A7 out. I'm going to move my ground over here, so to row 9, and that way the power comes in, goes to both resistors at the same time, and then it comes back out and returns. Okay, so those are our two pathways now. Okay, and so what we're going to do here now, we're going to use our jumper wires that have the alligator clips on one end. Okay, so we looked at these in the previous video. Now we're actually going to use them. And so what we'll do here is to keep consistent with the pictures, I'll use the blue wire with the yellow alligator head as connected to the A7 port on the device. And then the all white one, okay, I'll plug that into one of the ground ports. Okay, and then this will allow us to actually clip right onto the resistor itself. Okay, so this is important here because if we just were to use regular jumper wires and plug it in, we're not going to get the voltage drop across just the one resistor. Okay, so the A7, I'm going to plug into the top side. That's the same side that's connected to the 3.3 volt port. And then the white one, I'll plug it onto the side of the resistor that's connected to the ground. Okay, and that will allow us to measure the voltage drop across that resistor. Okay, then to measure it across the other resistor, we'll just move those alligator clips. Okay, and now you should be able to, using the A7 sensor, to get the voltage across each of those, the voltage drop across each of those resistors. Okay, and then you can be able to look at that and say, figure out how voltage behaves when the resistors are placed in parallel with one another. So you'll be able to determine how voltage works in parallel circuits. Okay, and then we'll look at how does current behave in the parallel circuit. So to do that, we're going to bring our 1 ohm resistor back so it can act as our ammeter to measure current. And so what I'll do to measure the current through the whole circuit is I'll place the 1 ohm resistor, right, in row 9 and 17. Okay, and then so now our circuit ends over here, so I'm going to move the ground over to row 17 as well. Okay, and so now in this circuit, we kind of have a combined circuit where we have 2 resistors are in parallel, but then those 2 resistors are in series with the 1 ohm resistor. Okay, so the current will go through, it'll split up, okay, through these 2 resistors and then recombine and go through this resistor. Okay, and so what we'll do now to get the current, remember we want to use the high gain sensor. So we'll move our A7 wire, the wire that's plugged into A7, we'll put that into the G+ port. And then the ground one, the white ground one, will move to the G- port. Then we'll plug our G+ to this side of the 1 ohm resistor. Okay, the side that's of the resistor that's closer to the 3.3 volts. And then the white one, the negative high gain, will plug in closer to the ground, the side of the resistor that's by the ground. Okay, and then we can get our current through the entire circuit. Okay, so the total current going through the circuit. But is the current the same going through each of those resistors, or is it different? Okay, so to determine that, we're going to need a second 1 ohm resistor so that we can basically have a second ammeter and measure the current going through each resistor. So you notice that in figure 10, what I do is I kind of move the resistors around a bit. So let's go ahead and do that. And so that 4700 ohm resistor and the 1 ohm resistor, I leave in the same place. But then what I do is I move the 10,000 ohm resistor from the end that's in row 9, I'm going to move it to row 7. Okay. And then I'll get another 1 ohm resistor, and I'll plug that between row 7 and row 17. Okay, so that will allow us to measure, so this 1 ohm resistor will allow us to measure the current through the 4700 ohm resistor, and the other 1 ohm resistor will allow us to measure the current through the 10,000 ohm resistor. Okay, and then again, we can just move our high gain wires, measure it over the first resistor, get the current going through the 4700 ohm resistor, and then we can move it to the other 1 ohm to get the current going through the 10,000 ohm resistor. Okay, and then based on those numbers, you'll be able to see how current behaves when it's in a series a parallel circuit. Okay, and then you finish off the lab with, there's some instructions there on how to use Ohm's law to calculate the equivalent resistance of this circuit. Okay, and it's a little bit trickier, so I don't expect you to figure out completely how it works. So in the summary of the lab, you'll see I'll do the derivation so you can see exactly how it works, okay, and why it works that way. But you'll still be able to see a difference from how resistance works in series circuits compared to parallel circuits. Okay, so that's everything I'm going to show you for how to set up physically everything for this lab. And remember, like in the instructions, I have a note there saying this lab report is worth 40 points instead of the regular 20 points for a lab report, because this is a pretty long lab. So it might take you a little bit longer than a typical lab. So you're putting in twice the work, so I'll give you twice the credit for that. Okay, and that's it for the setup for the Ohm's Law lab.